One of my favorite things in Souls games, and especially Elden Ring, is the weapon system. This weapon system categorizes the weapon into archetypes, and every archetype plays differently. You can't play a dagger with the same style as you do a greatsword, or a spear, or a great axe. This makes it so that every new weapon you encounter feels familiar but also has its own unique flavor. And since every game developer makes a Souls game at least once, I decided I'd adapt this weapon system and try and implement my own version. This video will serve as a tech dive into the weapon systems I ended up recreating in Unreal Engine 5 and its gameplay ability system. I'll first start off by talking about the scope and the goals of the system, then go to the approach, and finally I'll talk about the implementation and what I could have done better. Hey, my name is Idhant, and welcome to this devlog. Intros aside, here's the concept I came up with. We'll have a generalized base class upon which all of these weapons can be built. This class will also contain important variables. This also allows us to have generic methods like equip and unequip that should be on all weapons, but it also allows us to make our weapons different and take a more data-driven approach. The base weapon attributes look something like this. Using that as a blueprint, we can now construct many different types of weapons. This now allows us to make universal methods by adding and removing from the base class, but also allows us to make specifics by adding to the individual weapons. This makes it so that our attacks, stamina costs, our damage can all be derived from the weapon itself. With that, our base goals are now set. We want a system that gives us a generic solution to many different weapon types, is compatible with differing stat values, and offers support for further scalability. Now that the planning's done, the implementation is pretty straightforward. This is how the base weapon class looks. It inherits from actor and weapon interface. That interface has your generic weapon pickup and drop methods. For picking up, we simply pass ourselves to the inventory component and then destroy ourselves. We do this because the inventory component owned by the player will be the one that creates a weapon instance. This does a bunch of things, including firing our UI events that updates our respective weapon icons. For weapon drop, we just detach from actor and set our physics to true. Now that the weapon is in our hands, it's time to attack. The player has an ability system component which has a light attack ability that fires off when you press the attack button. This does a few things. First, after our prelim checks, it asks the inventory system to see if we even have a weapon equipped. If we do, we cache all of the required stats for this action and then ask our attribute sets if we have the stats to execute this task. In Elden Ring, when you don't have stamina, it's not like you don't swing, you just do reduced damage. If we detect we don't have any stamina, we just reduce our damage and our attack speed. Finally, we create an effect spec that's applied to the player. Now we just need to do a calculation for which part of the attack string we're on and then play that animation, and that's our system done. Although straightforward, the system allows me to create any weapon with any animations and any custom properties. All I have to do is create a blueprint from the parent class and populate it. We can have a great sword, we can have a short sword, we can have an axe, and even a comically large frying pan. It's like adding new weapons. Adding new functions and features is relatively straightforward. Tweaking damage numbers and stamina requirement just boils down to changing the value on the weapon itself. Adding new attack strings means adding new animations and hooking them up with animation notifies. But some additional things that I could add are weapon stat values that compare the player's stats to the weapons, and special attacks like Elden Ring's Ash of War. Overall, I'm pretty happy with this system. I know there's always ways to improve, and I've already rewritten the system a few times. But our initial goals have been met, and I've learned a ton about system design in Unreal, and most importantly, it works. So, I'll leave it at that for this system. Thanks for stopping by, and you can check out my other work in the description below.